Detection tells you an attack has started. Mitigation decides what to do about it, ideally within seconds and without harming legitimate users. First, we classify all traffic on the network. The good, for example, Apple TV Plus streams, and the bad, DDoS. The moment Defender sees DDoS traffic exceeding a configured destination value, it raises an event. Mitigation then springs into action. Defender pushes a handful of filter rules to the edge routers, or if the asset is very sensitive, an always-on appliance blocks the flow from the very first packet. The goal is simple: keep the target online and keep everyone else's traffic untouched. Think of detection as the alarm bell and mitigation as the automatic fire suppression system that follows it. Legacy threshold systems often block 10% or more of good traffic, while Deepfield Defender trims that to well below 2% and still misses fewer attacks. With a simple baseline threshold, you end up declaring attack anytime traffic doubles, even if it's only a software update or a game launch. That can inflate false positives into the double digits. Defender's context-aware approach, powered by Secure Genome, cuts false positives into the low single digits, typically under 2% in production. At the same time, by understanding who's really talking, it slashes false negatives. Genuine attacks that once slipped through are now caught in the first evaluation pass. Better context means that you can block less good traffic and still catch more of the bad. Traditional tools watch for sudden volume spikes, while modern systems add device identity, protocol intent, and destination context to decide whether a flow is malicious. Legacy detection is blunt. Set a baseline, raise an alarm if bandwidth or packets per second shoots past it. And that works until Microsoft ships an Xbox patch, or traffic naturally triples. Defender adds richer signals. It checks what kind of device is sending the traffic, what protocol is it using, and whether that protocol even makes sense for the destination. If 500 security cameras start sending quick packets to a gaming server, that's clearly wrong. Whereas if Netflix cache nodes deliver video streams to subscribers, that's fine. The difference is context, not just quantity. The more you know about who's talking to whom and why, the easier it is to tell attack traffic from business as usual. Secure Genome is a constantly updated census of the internet, built by active scanning, passive observation, and threat intelligence feeds. It tags each IP address with what it is, what software it runs, and how it typically behaves. Our scanners touch every routable address, recording open ports, TLS banners, firmware fingerprints, and even residential proxy indicators. We enrich all of that with additional threat intelligence, malware indicators, known command and control hosts, and abused IoT brands. Every entry is timestamped and versioned, so the system knows not just what a device is, but how that picture has evolved over time. Secure Genome is essentially a living map of the internet's devices and their habits. By telling Defender exactly which devices are sending each packet, Genome lets the system filter surgically instead of swinging a blunt threshold. When traffic spikes, Defender checks Genome. These IPs belong to Netflix cache nodes, leave them alone. Those IPs are compromised cameras that rarely speak quick, you can drop them. Because the decision hinges on identity and behavior, Defender can pull the rug out from under an attack while letting ordinary users browse, stream, and game without interruption. In live networks, that context has cut collateral damage from double-digit percentages down to the low single digits, even during multi-hundred gigabit incidents. So Secure Genome supplies the context. Defender turns that context into precise, low-impact protection.